That was really great.
Okay, let's get started. Before we get into Grasshopper, I want to give you a quick overview of what the platform is and why we are interested in using Grasshopper. Because in a way, you're in different programs, and as we know as designers, we are always introduced to different tools. And with introduction of softwares and different platforms, in the sense that's just adding to our toolbox, right? So it's not really any different than being introduced to a new machine or being introduced to a new type of maybe a material. So ultimately it has its own advantages, but at the same time we should be aware of, in a way, the overall setup. So a brief introduction of what Grasshopper is. Grasshopper is a plugin, as you know at this point, that sits in Rhino. And ultimately, whenever that you hear the word plugin, it's ultimately a custom functions written and developed by someone that was probably sick and tired of doing the same thing over and over again. And what they do is they package set of functions into a plugin or a library, depending on the platform that you're using, and that becomes then accessible. So some can argue that Grasshopper is in the way that we're using, the way that we are in a way sharing the information is open source, but in reality, in a technical sense, it's not, because you need to purchase Rhino or find it somehow and then be able to use this plugin inside. However, the way that the Grasshopper community has grown, it is quite similar to other open source platforms. So Grasshopper was introduced by David Rutan, who was an employee at McNeil in 2007. And it was a side project that he was developing, and he presented to his colleagues in 2007. So in the beginning it was called Explicit History. And why this term? Well, I'm not sure if you've noticed, but if you go to Rhino, after service release 4.8, there's an option down here. It says record history. So, sorry, let me minimize my window here. So one of the options here is record history. And if you're using Rhino 5, there's this pyramid here. These are also the icons to record history. So what does this mean? Well, we know that if we want to loft or create a surface in Rhino by lofting two curves, how do we do that? You need two input curves, and these could be any type of curves. It could be polyline, it could be any type of, let's say, interpolated curve. And as long as you have more than one profile, then you type in the command loft. Then you select your curves in the order that you want them to be lofted. So everything then has an order. Then you enter loft. It gives you certain options, then you press OK and you're done. But if I change my mind and if I want to, let's say, modify this surface, or if I move this curve over, if you're using Rhino 5 and if you don't see what I'm doing here, which is the gumball option, so this was introduced in Rhino 5 and it's extremely, extremely helpful. So down here, there's an option here right next to OSNAP to turn your gumball on or off. So this is very, very helpful because you could do moving, scaling, and rotation operation using this gumball. So if you've used Maya, you have access to a similar type of gumball. So it's very, side note, so you'll be getting a lot of Rhino tips as well in this workshop. So if I want to then update the surface, then I need to delete it, type left again, same thing. And it becomes tedious because what if I'm not sure about my left, or for instance, if I don't want the direction to be a certain way, it becomes quite tedious. So what record history does, I'm going to now select my curves, I'm going to copy it and move it over, and we're going to try the same operation. However, this time, before we loft these two curves, we're going to tell it to record history. So this is this option down here right next to gumball. So if you turn it on, the color changes, it becomes darker. Then if we type in the command loft right now, first curve, second curve, enter, the outcome is quite similar, right? But if you then start to move your curves, where is my curve? Then the surface is now being updated. And I could do a number of changes here, turn the points on. It doesn't really matter because the surface that we've created is associated with the property of these two curves. So that's the whole story behind explicit history. So in 2009, this was introduced, 2008, 2009, and people were very excited about this. But the problem with this is that if I do then this next set of operations, then I need to keep hitting record history. So it's an operation that only applies once. So that's problematic, right? It's because it's going to reduce our workflow. And there's really no difference if you look at this surface, and as you saw, I was trying to flip the surface and I broke the history. So that's problematic. And one thing you could do, you could say that select, let's say, select objects with history. You can say cell objects with history, but at this point, because I just broke the history by just flipping, so the whole thing breaks apart. So this button is always here, but no one really uses it. But the term explicit history, or the way that in a way Grasshopper was conceived, was just based on this idea of recording history. So you're constantly remembering a number of operations that you've done to your geometry. And why is that important? It's important because that's what makes the geometry live. So far what we created in Rhino, it's called dead geometry, because once you finish an operation, then there is no trace of that, right? So it's dead. So that's how we're going to refer to the geometry. It's either going to be dead geometry or live geometry. So going back to this slide here, I collected all the terms that I've heard people use to refer to Grasshopper. So anything like parametric design, which is a very vague term, to let's say visual programming, or some of them spaghetti wiring, people have used to refer to Grasshopper. But one thing that is extremely important to us, and that's how we're going to talk about Grasshopper, it goes back to the term explicit. So what does it mean to be explicit? It means precisely and clearly express and leaving nothing to implication. So this is extremely important because after this point on, we're going to start to create connections between geometry, right? We're developing the systems. And you want it to be extremely clear, first of all, to you, and second of all, to person that's going to open the file after you. And you're in the studios or in this working environments that constantly requires sharing information, sharing files that you're creating. So this is something that we're going to emphasize in this workshop, which is how to be really explicit about geometry that you're constructing. The second term, I'm going to quickly go over this, is the term parametric design, which is something that you've probably heard many times. It's something that is also associated with the software, but it's not really parametric design that we're talking in terms of the stylistic movement that Patrick Schumacher is talking about, but we're talking about the concept of designing with parameters, which is not a new concept to designers. We've always worked with parameters, right? And the term algorithm. So an algorithm is a series of instructions. So as I said, being explicit is very important, because if we want to create, let's say, a surface that's then extruded, we need to be very clear about how we're constructing that the initial curve. So what is an algorithm? Algorithm is a series of instructions. So it could be something as simple as me not knowing where the workshop is, and I'm asking around and someone telling me that it's here. So it's very clear that where my starting point is, where my end point is. So then anything could be an algorithm, from the definitions that we're going to write for the studio to, let's say, simple geometry constructions that we're going to do in Grasshopper. So all of these are braiding algorithms. There's a starting point, end point, number of steps, 6 steps, very clear, and anyone can follow this, right? So again, what's really important for us to use these 4 points to be able to then communicate what we're writing to our teammates or classmates. So 4 important points are that there are many ways to write an algorithm. The way that today I'm going to do this definition, maybe later on you're going to find a better way of doing this. So we can, in a way, agree to what we're doing right now, but there could be other ways of arriving from point A to point B. writing an algorithm requires assumption. We need to assume that you all have Windows running. We need to assume that you have Rhino and Grasshopper installed for us to be able to go forward, right? Or an algorithm includes decisions. So this is you as a designer that need to make this decisions or deciding how much we're extruding, how much we're offsetting, all of that. But the most important part is the last part. An algorithm can be broken down into many parts. So today we're going to start to create bits and pieces of, let's say, a certain type of geometry construction. Very soon, definitely by the end of the workshop, you're going to have a library of definitions that you're going to be able to copy paste and construct your own version. So we're all going to cover the same concepts here, but once you go back to your studio, what you're developing is going to be different. So then the same braiding algorithm could be broken down in Grasshopper and using annotation. So it's really important to be clear what you're doing, use color coding, and start to separate different operations. One thing that's really important about using Grasshopper, not so much that it would allow us to pipe one thing many times, but the problem with many softwares that we're using is the default settings, because as designers we're not really trained as computer scientists or let's say a lot of these other things that it requires, and we're also borrowing always softwares from other platforms, AutoCAD from engineering, Rhino from jewelry design, right? So we're always borrowing. So then how can we start to be a little bit more subjective with the geometry that we're constructing? So what's really great about Grasshopper, and this is a slide that I'm going to refer back to all the time, and this is the way that I've tried to understand Grasshopper and the way that we're going to try to understand Grasshopper, or the way that we're going to communicate, the way that we're constructing geometry. Anything in Grasshopper that we're going to construct, it's going to be a series of data and action relationships that we're constructing. So data flow in Grasshopper is happening from left to right. So just like it's an agreement, just like in different languages have an agreement whether you're starting from right to left or left to right. But in Grasshopper, the way that data flows is going to be from left to right. What that means is that anything that is on the left side, or let's say if we're looking at a component here, and this is called a component. So a component is a custom, in a way, icon with a certain code written inside that would allow us to do a certain thing. So this is a button that we can move around, right? And I know like in a lot of countries, like for instance in China, they call these batteries because it has this handlebars or these grips, or they're called components. So all the components, they have three parts. They have the left part, which is the input, right? So we're transferring data from left to right. So all the left side variables that take input, these are called inputs. The middle part, it's the part that the action happens. So you have all the ingredients, you're putting it together, then you're making a cake, or you're extruding a surface. Then it gives us an output. What is the output? Output is a new data that then could be used to do more actions. So in this case, and these components are going to become very familiar to you very soon. We have a point, series of points. What is the action? We're constructing line between them, then that gives us output lines. We're taking those lines, we're dividing them, and so forth. So it really doesn't matter what I do after that. Just always remember this slide that we're constantly going between input data, action, output data. Output data goes into another action, more data. So why is that important? It's important because then this data could come from anywhere. So in Studio, maybe we're going to start with geometry construction, but then later on you can, instead of, let's say, a certain number value that you're using as your data input, you can use environmental data input, right? So, or you can incorporate structural input or material, let's say, certain type of qualities that you want to inject into your design as part of this data. So this data can come from anywhere. In this case, it could come from color information and number of visitors that different museums have, museums that are in a way storing this paintings, or the data can come from mobile devices. It could be, for instance, extraction of the accelerometer data, or it could become sensory input. So while you're developing your geometry, I believe that you're designing a bridge perhaps you start to incorporate certain sensors, or you're looking at ways that maybe the users can have an input into maybe the way that the facade elements are rotating. I'm not really sure what the exact objectives could be or how they're going to be developed, but just remember that all of that could be part of the design, or it could be traffic data, or it could be, let's say, climatic data. So just keep this in mind as we're, in a way, starting to look at the interface. Just remember, this is one of the reasons that Grasshopper is becoming very popular, not only in building science, but let's say in undergraduate or in different fields, because just like Grasshopper is a plugin in Rhino, there are plugins in Grasshopper, right? So again, what are the plugins? Custom functions that allow us to expand the capability of Grasshopper. So for those of you that have already downloaded as you know, this is where you would find where you can download Grasshopper, but this is more than just in a way a repository for downloading Grasshopper. It's extremely important for you to always have this forum open when you're trying to construct your own geometry or figure out what icon is what. And this is pretty much this is the primary reason why Grasshopper has become very popular and readily used, because any question that you have, I guarantee you that there are 50 other people that have already asked that question on the forum. So let's say something simple as curve division. There are pages and pages and many discussions, and what's really great about this is that you can post an image or your file and someone will get back to you very soon, someone that has already modified the file. And it's a very active forum, and even David Rutten, who's written the plugin, he's constantly replying to this questions. Another important in a way homework that I want all of you to do by next week, because it's quite short what we're doing here. It's this tutorial that was developed in 2009. This is the second edition, and it's pretty much the best one still out there. It's by Lift Architects, and it's a PDF. You can definitely go through it, let's say, in 6 hours. And what's nice is it has this source files. So not only you're reading and completely looking at the way that it's let's say these definitions are explained, but you have these example files that you can go through. So this is a really great resource. The other great resource under tutorials, if you go to videos, I highly recommend looking at this Introduction to Grasshopper webinar. It's about 2 hours. By the end of today, you should be familiar with, let's say, the beginning portion of this, but I recommend going through it. And then there are all kinds of tutorials that are more topic-based. And if you have time, I recommend going through all of this tower tutorial. So it has 4 parts, but it's really good. I'll be happy that at the end of the class to get all of your emails and send you a list that I've prepared to, in a way, refer you to certain tutorials. All right. So how do we launch Grasshopper? You type Grasshopper. So it's a window that we can move around. It's a floating window, and we need to get used to this because we pretty much have to always have it open. Just like any windows that you work with before, we can minimize or maximize it. and you can definitely move it around however you want if you grab it from the title bar. And if you double click on the title bar, you'll be able to completely minimize it, and you would only be seeing the title bar. So we haven't named our file yet, so therefore it says no document. Just if you could just quickly tell me, does anyone here have any Grasshopper experience? Slightly? Yes? Okay. Great. So what we're seeing here, and what you're going to be seeing, is going to be slightly different than what I have up here. If you're just launching Grasshopper, your tabs are only going to be going up to transform. So all the other tabs that you see that I have here, these are all other plugins that I've already installed. So we're going to look at some of these later, but so far your tabs are going to start from parameters, and we're going to end with the transform tab. So we looked at the title bar. It allows us to move around. Then we have our menus here. So some of the content of these menus are quite similar to any other Windows program. For instance, under Edit, we can copy paste. Under View, we're dealing with visibility, and Help is also, it's always our friend. So if you have any, let's say if you have any Grasshopper support, you can launch this. It's very, very useful. So where we'll be working all the time is going to be between these tabs here. So these are tabs that have grouped components in them. So this is quite similar to, let's say in Rhino, you have your curve menu here, then you have all the other operations that has to do with curve under here. We have then surfaces, meshes. So some of these are geometry based, but some of these are more generic. For instance, anything that has to do with analysis or transform. So if we go back to our Grasshopper tabs, you would see that some of these are familiar. For instance, the curve tab, we know that in Rhino we have a curve tab, or the surface tab, but we don't have any solids. So solids are poly surfaces, right? So more than one surface. So in Grasshopper, anything that has to do with poly surfaces, they've already they package that under surfaces. So surfaces, we're talking about the geometry type of the surface, NURB surface that has, we know, control points, degrees, knots, all of that. Then we have our meshes, intersects. So intersects, we would be able to do Boolean operations, extract, let's say, intersections. And under transform, we'll be able to do everything else that, for instance, it's part of our basic menu, moving, scaling, mirroring, as well as some of the functions that we have in our transform menu here. But the first three are quite different. The first one, the parameters tab, or the params tab, this would allow us to input geometry or input data, or transform geometry or transform data. So as the name indicates, parameters, these are going to be in a way the kits that we're going to play with. So from, let's say, certain geometry types that we're going to reference in Grasshopper environment, to, let's say, numerical values that we're going to use to then change our variables. So anything that has to do with transferring geometry or inputting geometry is going to be here. Under math, we're going to be working with writing logics, expressions, or relationships, or extracting numerical values, for instance, domain of the curves or surfaces, or domain of the variables that we want to, let's say, input. And we could do some advanced logic here as well, whether we're using the default components here that would allow us to set relationships, true or false relationships, or we're getting into more advanced scripting. Under sets, this would allow us to, in a way, assign addresses to the geometry that we're creating. So we're going to get into that later, but this would allow us to be able to sort our geometry, or select certain geometries out of a list. And under vector, this name is a little bit confusing. They've organized all the groups, component groups that have to do with basic geometry construction. So imagine if you want to construct any type of a geometry in Rhino, you need to make sure that you're on the right plane, right? You're using the right plane, or you're using some reference points, or let's say if you want to use a construction grid. So anything that has to do with basic geometry construction guidelines, they've organized this under vectors. Okay, so in the first definition, and what we're writing here is called a definition, we're going to in a way work together. And before we start this, I'm going to tell you what we're constructing. We're going to write it in plain English, and after that we're going to go step by step and construct our geometry just based on this instruction. So this goes back to when in the presentation when we were talking about in a way stating the steps one by one. So at this point you can see that what we have under our menus here, we have a text here. It says either drag a new component onto the canvas or double click. So this environment here that you're seeing that we can zoom in and out, this is called our Grasshopper canvas. So this is our canvas. And if you hold down your right mouse click, we can pan around in this environment, or we can zoom in and out. And you can see that there's this guideline here, but this doesn't really function as an origin. So we cannot really snap into this Grasshopper grid as we would do in Rhino. So for me to be able to write this notes, I'm going to use a component that doesn't really construct geometry, but it allows me to just write my thoughts, write my ideas of how I'm going to do this. And we're going to find this component under Parameters tab, under Input. So if you left click on this Input tab here, you'll be able to look at all of this other components underneath here. And this component is called a panel. And you can see that it looks like a post-it note with just this, in a way, this scribble on there. So hold down your left mouse button and drag and drop that on canvas here. You can select this panel and move it around. And you could start to extend the size. So it tells me that double click to edit panel content. So let's double click. So now we could write a note to ourselves. So we're going to do a very simple setup. First, I'm going to construct a point at the origin, 0, 0, 0, and we're going to call that point A. So I'm going to say create point A at 0, 0, 0. Enter. And we're going to say create point B at 0, 0, but I'm not sure how far I want the Z to be from the first point. I'm not sure about that. So I want to keep this flexible. So I could say that just some kind of a Z. I'm not sure what the Z is yet. Then we're going to create a third point. We're going to say create point C at 0, 0. And right now, the point 1 and point A and B, I'm not sure what the relationship is in Z direction, but the way that I want to establish this, I want to say that whatever this Z value is, whatever this point B Z value is, for point C, we're going to do Z, let's say, plus 4. So therefore, the relationship between point A and point B, it's not fixed yet, but relationship between point B and C is always fixed. Then we're going to draw a line between point A and B. Then we're going to draw another line point B and C. We're going to pipe both of these lines and draw, let's give this a name. Draw line 1 between point A and B, and draw line 2 between point B and C. Then we're going to pipe line 1 and 2. Then we're going to apply color to them. So this is very clear. You could write this and maybe you would only get to, let's say, 4 points, but you can pass this file to your teammate and they can continue working on this. Or you can come back and you can follow your, in a way, thought process. This is okay, but you could see that it's a little bit, for instance, what if I didn't enter this here? How can I align this? So, because this is a panel with multiple lines of information, what I could do is I could right-click on this panel here, and I could tell it to convert this panel to then take multi-line data. And what that does is, you can see that immediately it assigns an index to each of these instructions that I've written. And this is very important because in Grasshopper, we're constantly going to be working with lists that have this index associated with them, right? All right, so let's start. And I can move this panel wherever I want. First thing we're going to do, we're going to construct a point at 0, 0, 0. So there are 3 different ways that we can construct point in Grasshopper. The first way that we're going to cover today, it would allow us to construct a point by taking 3 different inputs. 1 input for X, 1 input for Y, and 1 input for Z. If you remember when we were going through our different tabs, we saw that under our vector tab here, we have a whole group of components that would allow us to construct different types of points or use, let's say, these properties of the points to then, for instance, calculate distance. So from this point on, anything that has to do with points, we're going to find it under this subgroup here. So the first option here, it tells us that it would allow us to construct point. And as you know, that Rhino is a very friendly software, so it always tells you, for instance, what you're looking for. If you start to search, it would give you other options. So it's really, really crucial for us to always read these instructions, because later on we would see that there are many different, let's say, components that would allow us to maybe have the same start, but the output might be different. So this first one, that's exactly what we need. We want to construct the point by having 3 different inputs, X, Y, and Z. So let's drag and drop that on our canvas here. And as soon as you drag a point construct component on canvas, and you could see that if you're using a different version, it's not going to be called construct point. It's going to be called point XYZ. Yes. So this is really important because in different versions, they start to, in a way, they're developing this. So finally, Grasshopper is in version 1, but this is very common to perhaps what I'm looking at here. It's not really what you're seeing. So so just pay attention to Rhino environment here. As soon as you drag and drop this construct point component here, you can see that there's this icon here that we know that Rhino, it indicates points. If I try to select this, that's not possible. The reason for that is that Grasshopper allows us to construct this geometry systems inside its environment, and until we tell it that we want to do otherwise, we're only going to look at geometry previews. So right now I'm only looking at a preview of a point. So only looking at a preview of a point, and this point doesn't exist. But if I click on this component here, you could see that the color is changing. So by default, all the geometry that we're going to construct in Grasshopper is going to be red, and when you select it, it's going to be green. Is anyone colorblind here? No. Okay. Yeah. If you ever want to change this setup here, my partner is colorblind, so we always have to in workshops be very specific with this. But if you ever want to change the color of the default settings, you see that we have this icon here. It says Document Preview Settings. If you click on it here, this sometimes is buggy, but you should see this window that pops open. Yeah, can you guys see it? Yeah. Okay, sometimes it's buggy. So you should see a window. This is really odd. I don't want to restart, but you should see a window. It gives you the color wheel and the default color, so you can pick whatever you want as your default colors. But this happens a lot, so sometimes this would just require me restarting. So. Alright, so let's look at what this component is. As we said, in Grasshopper we have our inputs on the left side, the action, so this is the in a way the belly of the component. This is where things are being mixed up. Then we have an output here. And what's really nice about this Grasshopper is that if you hover over any of this inputs or the actions, it gives you really explicitly what it's doing. It tells us that there's one locally defined value, which is 0. One locally defined value, which is 0. And then it tells us that the point has an output, which are the coordinates of this point here. So just like here, we use the panel to then construct our pseudocode. So a pseudocode is a way for humans to talk to machines, right? So we're just writing the operations of what we're going to do. So I could also use a panel to then look at the content of our components. So we looked at previously one way that we can access these components. You can go back to the main menu. You can go through the sub-menu, drag and drop that on canvas. But if you know exactly what component you're looking for, so if you don't want to go through all the menus all the time, if you double click on anywhere on canvas here, you can see that there's a search bar that's appearing, and if I know that this component is called a panel, then I could say that I'm looking for a panel. So this is a really quick way to look for components. But just be careful, because some components, such as let's say a point, so if I double click and type in point, you could see that I might get something different. And if I'm not sure if this is the same, or if I'm not familiar with the icons, you could see that this now is a different component. So just be careful what you're looking for. And now, as you can see, that I'm going to, as this panel here, we're going to use it to then read the content of this component here. So we have these grips. Most components have an input, let's say one or many input grips, and they might have one or many output grips. What this grip would allow us to do is to transfer data. So if you hold down your left mouse button here, you can extend this wire out of any component and connect it to the next component. So right now I could see that my point is created at 0, 0, 0. So components that have grips, they could take this, we could start to create these relationships. So this is ultimately our point A, right? We've already constructed this. But I want to be a little bit clear because we're going to have 3 different points here. So one very common convention that we could use to name our components is by grouping them together. So right now I want to group my panel to my component here. You could do that by going to Edit and tell it to be grouped, or the shortcut is better, Control G. It allows you to group many components to one another. I could group a component to itself. So if I want to only group this component to itself, I could also do that. Why is this valuable? Because when you group this components together, then if you right click, it gives you an option to then write, let's say, these notes to yourself. So then I'm going to name this group and I'm going to call that point A. And when you group, just like grouping in Rhino, then you can move things around together. So if you right click on the color part here, you can see that we have a lot of different options here. So right now by default what we're looking at is the box outline. So we can start to then look at different types of grouping options. Another way that you can access this grouping option is by double clicking on the color part. So for instance, if you have the blob setting, then you can separate them. But if you have the box setting, you cannot separate them. So depending on what you want to do or how you want to group your components, that's possible. Okay, so then the next thing we're going to do, we're going to create our point B. So I know that I need one of those components, the point XYZ component. So we can go to vector again, point, grab, and construct point component. But what is happening right now? I'm only seeing one point. Well, they're overlapping right now, right? Because the default setting is set to 0, 0, 0. So that definitely needs to be changed, because in this case I want to vary their z value. So how can we start to then change this inputs? So just like we right click on this menu here and it gave us more options, any of the variables here, whether it's the input or the output, if you right click on the variable, it would allow you to access in a way what is happening inside the component. And that menu option is going to be different whether it's the input or the output. So it's quite specific, and it's the way that it's set up is very clear what needs to happen. So one of the things that's important, I'm right clicking on X right now. You can see that we have an option here that we can change the name. So instead of X, I could change that to A. So any of the variables, I could right click and change the name. So instead of point, instead of grouping, I could call that point A, or I could call it USC, whatever I want. It doesn't really matter, because we're not really changing what's inside the component, we're changing the way that we're calling that. But then what's the problem with this? The problem is that next time that you open this, maybe you're not going to remember how you've named this. So I really, really do not recommend this. And therefore this grouping is always a good option, because then you understand that it's just the way that you need the component to be for this specific task is changing, not really the component. Okay, so let's go back to X. Then while we're inside this menu, one of the things that I want us to pay attention is this option here. It tells us that we can set number. So by default, this value that we're seeing here, the 0, is this number that's set up here. So if I change this number to, for instance, 5, you could see that now my point is at 500. So my point started to move. So something that we need to clarify right away is that in Grasshopper, we're not really working with specific units. Grasshopper always inherits whatever your Rhino file is created in. So you can open the same definition file, and if your main file is in meters, it's going to then adjust all the relationships in meters, and you can open then the same file in inches, and everything will be scaled up and down accordingly. So then in this case, it's 5 units of whatever my base file is. So if you right click, go to set number, then go inside the box and change it there. Sorry. Let's turn off the grid. Maybe it's a little bit confusing. The shortcut for that is F7. If you guys don't know, so with F7 you can turn on and off the grid. This is good, but if I don't have this panel, this component doesn't look any different than, let's say, the one that is at 000. Unless I, let's say, hover over it or do something else to it, in a way, by looking at this, I'm not going to know that this is exactly the way that it's constructed. And as you know, we can click on them, and it's going to highlight the specific one that we've created. So even though we can change the default value here, but I do not recommend it. So just like here, where we're using panels to then look at our outputs, we can also use panels to then, let's say, have inputs that are going into components here. So I can drag and drop a panel here, and this time we're going to use a panel to then input a value, for instance, 10, into our X. So panels are extremely useful, and I could copy paste them just like I could copy paste any component. So all the shortcuts that you know, Control C, Control V, or Control X for cutting, all of those apply to all of our components here. So if I go back to my instructions, this is going to be my point B, but the way that I've written this, I'm not really sure if Z is 10. I want to write it in a flexible way that I could then go back and change it. So the problem with the panel here that we're using as an input is that if I want to change this to, let's say, back to 5 again, I need to, in a way, double click, change it. It's a little bit tedious. So another way that we could do this, but in a much more efficient way, go through all of our input variables, is by using a slider. So under parameters input, which is where we grab our panel. Do you have any questions or? Yes.
My point is red, not the point, but the actual.
The panel. Okay. So if you are in your panel, if you have this number, if you double click on your panel, you're going to see that your cursor is on the second line, right? Okay. So what that does is it tells the panel that it's expecting for another line of information. So then it's going to be red. So make sure that anytime that you're using panel to input variables, that you only have that one specific line.
How would you like sever like switch it?
Okay, I'll get into that. So how do we start to then play with this component? How do I, let's say, disconnect this, or how do I, let's say, replace this? Anytime that you want to disconnect a component, there are a few ways that we could do this. If you right-click on this input here, you would see that you have an option here that tells you to disconnect the panel. Right-click on the X input here, and it's going to have an option that says disconnect. It's going to allow you to disconnect this wire. But we're going to do this connection and disconnections all the time. So if we want to do this faster, if you hold down Control, you would see that there's this minus sign that's appearing, right? And that would allow you to disconnect your components. And this disconnection could be from either direction. I could disconnect from one end or the other end. It doesn't matter. I could use the same input to then input into two variables. So right now, my X and my Y are 5. And if I then change my mind, I can hold down Control and disconnect, for instance, X. But we said the problem with this panel is that then we need to edit it one by one, so it's quite a slow process. So panels are really great to if we have a variable that we're certain that we're going to use, we're not going to change. So it's good to use a panel for that. But for any type of variable that we're not sure what it is, we know that I want it to be between this number and this number, and I'm going to look at the range and figure out what it is yet. Then we would use another input type, which is a number slider. So parameters, input, number slider. So we know that already this number slider doesn't look exactly like anything else that we've seen so far, because anything else we've seen so far, it has this input grip and the output grip, right? But the slider, it only has this grip that allows you to send information out. So I'm going to grab a panel to have a look at the content of the slider. And all it tells me is that the value right now that I'm on is 0.25. But what's really great about this slider, if you with your left mouse button, if you grab this this node here, you can start to then go through various number within this domain that you have, right? So it seems that the lowest bound of my slider is 0, and the highest bound of my slider is 1. So what is a slider? Slider is ultimately a graphic domain that allows us to go through all the possibilities, right? So what that means is then I can now use the slider and I can start to move things around. I can start to use the slider and if you remember, what we want in this case is a point B that's at 0, 0, and Z. So I don't really need this. I could just delete this. So if you're a Mac user, to delete, you need to do function delete. And I could then connect this Z value into the Z input here. see that if I then go through my slider, my point is moving in z direction, and we can start to see the coordinates, how they're being updated instantly, right? So, do I need these panels here? Not necessarily. These panels are just only helping us to see what is inside the slider. So I could hold down Control here, disconnect this panel here, and connect the slider directly into my Z. Also delete the panel. And you can see that immediately when this is connecting to the input here, it tells us, it immediately changed the name of the slider. So then if I copy the slider up, then if I connect it to X, it would tell me that this is a slider that's controlling the X coordinate. And this is a recent development. In previous versions, they were all called sliders. Or I can use the same slider to then control two inputs, right? So now we're going diagonally. But this is very limiting, because right now the domain is only set between 0 and 1. What if I want to be able to, let's say, move in, I don't know, 20 units in either direction? How do we change, how do we edit the content or the domain of this slider? Any slider that you have, if you right click on the slider here, we can edit the content. We can edit properties of the slider. So right click, go to edit, and you can see that here we can see the numeric domain of the slider. So if I then want to, for instance, change the domain to, if you double click and change the domain to 20, click on this green option here to confirm the changes. Then if you press OK, now we can extend the domain. So by default, the sliders have 3 decimal points. That's the way that they're written. So if you go back to edit again, if you hover over this R option here, it tells us that right now our slider is taking floating values. So floating points or floating number types are ultimately decimals. And we have then 3 decimal places. So we can then edit the decimal places, or we can completely change the type from, let's say, floating type to integers. So if you're working with, let's say, an input that is, for instance, number of divisions, it cannot really be decimals, right? It needs to be integers. So then you can change the type. So I'm going to disconnect the X here. I'm going to hold down Control, disconnect the X. And if you remember, we had a setup, we had a default value here that we were tweaking. So I'm going to right click on on X, change that number back to 0. And once we have these 3 elements all together, I'm going to group them all together, select them, Control G. I'm going to right click and call this point B. So right now we have these two separate points, but you know, in Rhino you can let's say organize your information in layers. You can lock them. You can turn them off. So how do we manage data in Grasshopper? If we're only looking at previews, then can we turn off the preview? Yes, of course. If you, for instance, if we want to turn off the preview of our point B, if you right click on any component, you could see that it has a preview option here. If you turn off the preview, you can see that this point is still being created. It's just we're not seeing it. So another thing that's really important is that the color of your component is changing as soon as you change the preview off. If you then right click again, you can tell it to be previewed again. Or right under preview, we have another option. We can either enable or disable components. When you disable components, now this is a different color. It has this different gray tone. I'm gonna right click and turn off the preview of this. You can see that they look different. When you disable a component, you can see that it's not really generating a point. However, when you turn off the preview, it's still generating the point, we're just not seeing it. So when you disable a component, you're telling the program not to compute that component. So it's completely not being computed. So a lot of times when you have a lot of geometry and if you want to make your file a little bit lighter, you can, let's say, disable certain parts. So we're going to learn two very important shortcuts that we're going to use over and over again. And yes, we can right click and play with the preview, but the problem is that if I have more than two, I cannot really turn the preview on and off altogether. I need to do it individually. But if you select more than one component or even one component, if you want to turn the preview off, the shortcut for that is Control Q. So Control Q allows you to switch between on and off state. Meaning if they're both on, they're going to be off. And if they're off, they're going to be on. So if I have one component that's on, the other one is off, I'm going to switch the relationship, right? So the other one is going to turn on, the other one is going to turn off. So just be aware that it's really important because we're constantly seeing a lot of geometry, so you want to be able to manipulate only what you want to see. The other shortcut that we're going to learn is Control E. So when you use Control E, you are able to disable your component. So for preview is Control Q, for enabling or disabling is Control E. And it's the same type of on and off option. If one is enabled, it will be disabled, and the opposite. Okay, so now we're going to create our third point here. At this point, I could either go back to vector, point, grab another construct point component, or we can just copy this component down. So a lot of times, if you're going to repeat the same operation over and over again, I could just select that specific component, Control C, Control V, and I'm going to move it down. And if I don't want to connect to this slider, then I could hold down Control and disconnect it. So right now this point C, or this third point, it's overlapping with point A, right? Because it has the same default values. And if I want to quickly see this, we can use a panel. So we're going to learn a really useful shortcut for panels. If you double click on canvas here, yes, you can type panel and grab it, but because as you see that we're using panels all the time, if you double click on canvas and then write quotation mark, it would know that you're looking for a panel. And this is very useful because you're just you're cutting down steps, right? But for instance, if I'm looking for a panel with a specific number inside, because if you remember what we're saying is that for point C we need Z plus 4. So for instance, I need that number 4. It's a specific number, and it's not a slider, but it's a very specific number that is important to my geometry. So then if I want to have a panel with a specific number inside there, instead of grabbing it, typing it inside, I could double click on canvas here, type quotation mark, then that specific thing that you want to have in the panel. So quotation mark 4, it would give me a panel with the value 4 inside there. Okay, so what I need to do is then what? Just add that Z value, whatever that Z value is, to this 4. So where does my Z value come from? It comes from the slider here. So I need to then add whatever that number is to this 4, and the resultant is going to be then fed into my Z input here. So if you remember when we were looking at all of the options here, we have a menu here that's called Math. And not only we can do some complex scripting here, but we can do some basic math operations in here too. So what I need to do is a simple addition. So let's go to math operators and use this addition component here. I'm going to move this over and let's see what this component is asking for. It's asking for input A, input B, and it's going to add those and it's going to give me the resultant. So my input A is going to come from my slider here, and my input B is going to be this number inside the panel here. And if I hover over it, it tells me that right now it's 15. So what's really great about Grasshopper, immediately you can check whatever it is. Now the resultant goes into my Z value here. So now it doesn't really matter what my point B's Z value is, because point C is always going to be 4 units above point B. So last thing, I'm just going to group these 4 components together, Control G, and we're going to call this point C. Okay, so we are down here now. Now we're going to draw line 1 between point A and B. So what type of a geometry is a line? Curve. It's a curve, right? So it's a curve. So therefore, if I'm looking at my menus, I'm going to go to my curve component group here. And you can see that we have a lot of different subgroups. So in all of our 3 geometry types, these subgroups are quite common. So in all the geometry types, we have 1 or 2 menus that would allow us to construct the basic geometry types, they're primitives. So for instance, the primitive surface types, or the primitive mesh types, or the primitive curve types. For instance, circles, ellipses, or different interpolated curves. Then we have components that allow us to analyze what we have created. So then this would take any type of curve that we created and we can analyze it. What does it mean? To analyze it means we can extract information from it, we can evaluate it. So in all of these geometry types, we have components that allow us to analyze what we have. And if you don't use the Analyze menu in Rhino, it's extremely useful. It allows you to calculate length, distances, find centroids, etc. Then we always have this utility menu here. So with utilities, you can, once you have or let's say a surface or a geometry type, you can extend what you could do with it. For instance, all the offsetting and exploding, all of that happens under utilities. So under curve, under primitive, you're going to see that up here in the first group here, first segment here, we have all of our line components here. And there are many different ways that we could draw a line. So what's one way that we could draw a line? We could have a start point and an end point. Another way would be we can only have a start point or an end point, and if we know what is the direction of the line, meaning if we can have a vector and if we know how long the vector is, and that would be another way that we could draw a line. So the way that we could arrive to a certain geometry could vary, but depending on the basic, let's say, information that we're starting with, we might want to use one component or the other. So under curve primitive, we're going to use this component here, which would allow us to create a line between 2 points, because that's the information that we have. So what it's asking for is start point and an end point. So in this case, we're going to draw a line between point A and B. So let's construct this panel to A and this panel to B. So that's our line 1. So I'm going to group this component to itself. I'm going to right click and call this line 1. So we're starting to create this, I guess what you could call this parametric relationships, because as our slider is moving, not only point C is connected to point B, but also our line is also being updated. So that's what, let's say, record history would do initially. Then the next thing we want to do, we want to create line 2 between point B and point C. So I could copy this line component down, but when you copy components, you want to be careful, because right now this goes again from A to B, and I could replace it. So by default, Grasshopper components only take one input. So if I want to then, let's say, use this point B as the start point of my line 2, if I then input this panel here into A, you can see that it's going to replace what it was initially connected to. So by default, all the inputs can only receive one variable. So I can now connect this to B, then it's going to replace it. So we don't have to disconnect, then connect again. If you replace it, or if you then, let's say, use a new input, it's automatically going to replace an already existing input here. So now we have our line 1 and then line 2. So all I have to do is to just right click and change the name of this line to line 2. Okay, so next thing we're going to do, we're going to pipe line 1 and line 2. When we pipe in Rhino, what type of geometry we're usually getting as an output? Surface, right? So these type of questions are helpful, because if you're looking at this for the first time, how do you locate, let's say, the piping component? So under surface freeform, one of the options here is piping option here. So surface freeform pipe. one really useful shortcut that's going to be very handy, especially if you're downloading things online or if you're looking at someone else's definition, is a shortcut that would allow you to locate where the component comes from. So if you hold down Control and Alt together, and if you click on any component, it would draw this arrow which tells you where that component comes from. So hold down Control Alt together, then click on any component. Hold down Control Alt, then click on your component. Because with different versions or different things, it might really be, it's very difficult to go back and trace where things have come from. So this is very useful. Okay, so the piping component is, it has 3 different inputs. But before we go into this, one thing that I forgot to cover with the line component, because so far we've only looked at 2 different types of, let's say, component types when we input them on Canvas. If you remember, when we first input our point component, it looked like this. It looked exactly like this. It was grayish. Then it had certain numbers already embedded in there. But when we grabbed our line component, it was orange, or this piping component here is orange. So when components have certain values already embedded in them, they are already gray. But if they're lacking information, if they don't have enough information to, let's say, complete a certain function, then they're going to be orange. So if you right click, you could see that what it's still missing. Well, it's missing the input information, right? And red is not good. We had one red error earlier. So when it's red, it means that it's completely, it cannot, let's say, execute what you're asking it to do. Okay, so what the piping function or the piping component needs is a base curve or curves to pipe. So these type of actions, whether it's drawing a line or piping, the input could be singular or multiple, and we're going to look at that more later. So it's asking for a curve, but here my output is a line. So if I grab a panel to look at what I have here, it tells me that I have a line. And any time in Grasshopper that you have any type of a line output, in parentheses is always going to give you the length. So it's very, it calculates in a way that analyzes it for you as well. So you want to be just pay attention that a lot of these geometry types, you want to know that where it comes from. So we know that line is ultimately a type of a curve. So therefore it's okay for me to connect an L output to a C input. So a lot of these variables can be interchangeable, but for instance, you cannot use a component that is asking, let's say, for mesh faces. You cannot input surfaces there, right? So there are certain things that we could interchange, but as long as the geometry type, the basic geometry type is the same, then it's fine. So we can see that then the color is changing because this component, all it was asking for is a curve, because by default it has a radius already set in there. So the default radius is set to 1, and we know that if we right click on the input here, we can access that set number. So we can change it here, or at this point we know that we can change this with a slider. So let's drag and drop a slider here, a number slider, and connect the slider to the radius. And when I turn it all the way down to 0, then now I'm getting that red error because it cannot really pipe if there is no radius. But it goes all the way up to 1. So we saw that one way that we could edit the slider is by right-clicking and editing the information here, which is definitely possible. So this edit menu here, it takes you really inside. Like, not only you can change the domain, but you can change the type or the name of the slider. But if you only want to change the lowest and highest bound of the slider, you can do that by going to the second option here, which is to values. So if you only want to change the domain, you can change the values here, right? But you cannot change the, let's say, you cannot change it to odd or even slider or more detailed information that you find under editing here. So here I could change it from, let's say, 0.5 to, let's say, anything, 6. This is very helpful. It's a little bit shorter. But we're going to use sliders all the time. Just like panels, sliders are always going to help us to create this interchangeable parametric relationships. So another shortcut that's going to be very important is it would allow us to create very specific type of sliders. Okay, so if I want to create a slider that, let's say, because the default starts from 0 goes to 1, but if I want to create a slider that is maybe stopping on 5, but I don't really care what the start and end of the domain is. So for instance, I don't know what my radius should be. I just know that maybe the number that I want to start with is maybe 3. So I'm going to double click on a canvas here, and I'm going to type 3, then enter. So it would give you a slider that when you see it for the first time, it's going to be on 3, but the beginning and end of the domain is not really up to me. So if you double click on canvas, and if you're looking to get a slider, and if you type a number that's smaller than 10, 8, it's automatically going to assume that your domain needs to be between 0 and 10. And because I typed 8 and not 8.00, right? I input, my input was integer type, then it gives me a slider that takes integer types. If I want to then, for instance, have then floating points, if I then type 5.000, then my slider is going to have floating points with the exact number of decimals that I want. But what if I type a number that's greater than 10? For instance, 22, enter. Again, it would give me that specific number, but by default, it's going to assume now that my domain is different. It's going to assume that my domain is between 0 and 100. So any number that's smaller than 10, it's going to assume that your domain is between 0 to 10. Less than 100, it's going to assume that 0 to 100. And if I go then above, let's say 100, but less than 1,000, it would automatically assume it's between 0 and 1,000. So this way is okay, but it has some limitations, because then I have to go back and edit it again. So if I want to customize my slider, if I wanted to, let's say, have a slider that starts at 3, but then I want to then end, let's say, on 27. I'm going to double click, and I'm going to say that I'm going to have a slider that starts, the beginning of the domain is 3. And sorry, I need to update my computer, so that thing is popping up. So I'm going to stop on 3, but the end of my domain is going to be 27. So I'm going to say 3 less than 27, enter. So now we can set up the beginning and end of our domain. And as you can imagine, if I tell it that my, let's say, the type of my slider, I want it to be, let's say, with 2 point decimals, I could also do it here. I want to start on 13, and I want to have, let's say, 3 decimal places. Yes?
We don't get the
Right. If you're using Grasshopper, that is about in the previous versions, which are if you don't have Rhino, that's Service Release 3. The Grasshopper that you can install, it's not going to allow you to do that. You can only double click and get the number ones, but you cannot customize the slider. So if I want to start on 13 and go all the way up to 20, and I could do that here. But you don't have to, let's say, emphasize number of decimals on all of your inputs. I could say that only one of my values has 3-point decimals and the other one is integer. So it would just assume that that's how you want to do it. But what if I want to make a slider that has a specific starting point, let's say 13, but I want it to go up all the way up to 99, but when I stop, that specific number that I want to get is maybe 66. So I'm going to say start the domain on 13, so 13 less than. I want it to stop on 66 when I see the slider, and less than the end of the domain, 99. And I want it to have, let's say, 2-point decimals, 13 or whatever number, 13 less than 66 less than 99, and I wanted to have 2-point decimals, 99.00. Now I could be very, very specific. So these shortcuts are very, very important. So for sliders, you can set it up by this relationships, 0 less than 5 less than 10, enter. And remember, for panel, you double click. For quotation mark, it would give you a panel, and then you could tell it what you want to have in the panel, right? The other shortcut, Control Alt, click on the component. Then if you want to turn on and off the preview, you click on singular or multiple components, Control Q, and now you can see the line disappear, right? Or if you completely want to disable it, I want to tell it not to compute this line, Control E. But if my line is not being computed, then there is no surface. So you want to be careful with enabling and disabling, because if you're not really disabling the proper component, then you might really cut the lifeline of your geometry. Okay. So all of that, so we can create a slider for our pipe here. And in this case, I want to have a slider that it shouldn't start on 0, because 0 would give me an error, right? So it starts on 0.5 less than, let's say, I want it to stop on 5 less than 15. Enter. And the numbers are quite arbitrary. You could pick whatever number you want. And that would allow me to now go through different piping radii. The third option here is very, very important. If you hover your mouse over it, it's going to tell you that it's going to specify the types of caps. So by default, when you pipe a line, it's not going to have any capping option, right? But you could set it up. For instance, you could have the flat cap, or you can have a rounded cap. And how do we access this option? So what are the options when you loft something, or when you, let's say if you do certain operations, a lot of times you have options to, let's say, toggle between one or the other. So in Grasshopper, a lot of the operations, it would allow you to not only, let's say, change the variable, but also access certain options. If you right click on the end option here, you could see that you can toggle between different options. So right now my piping is flat. If you right click, you can have a rounded end, right? So what we saw was this none, which was the default value. So what's nice about this, it's already here, but then I need to right click and access this function here. But it tells me that also all of these options are associated with a number. So 0 meaning none, 1 meaning flat, and 2 meaning round. What that means is that if I had a slider that would allow me to go through these options, then I could quickly see these 3 options, right? So let's make a slider that starts, let's say, on 0. And we could tell it to go all the way up to 2, because our options were 0, 1, 2, and we want them to be integers, right? Enter. Now let's connect it to our capping option or the end option, and now we can toggle through these numbers and we can see these 3 different options.
The set number of options.
What do you mean?
And if we have a slider that's 4 instead of 2.
Yeah, then it would just not do anything beyond 2. Yeah, your slider could be, it could go all the way up to thousands, just not going to register it. Okay, so a few more steps left. Now we need to pipe our second line. So I could just copy this whole chunk of these 2 sliders and the pipe down, Control C, Control V. And right now we have 2 copy of this pipe lines on top of each other, right? And all I have to do is to just replace the input curve. So instead of both of these connecting to line 1, I can connect it to line 2. Then we can either change the capping option individually, or I could use the same slider, for instance this top slider, and connect it to both of these options here. And as you can imagine, I could do the same with the slider that's controlling the radius. When you select more than one component in Grasshopper, it gives you this alignment options, and these are extremely helpful because, as you can see, you can move these around and there's no really grid to snap to. But very soon this could get very, let's say, complicated, wires going everywhere. And what you could do is you could select your components and you could tell it to be aligned however you want. You can align it, let's say, you can adjust it to, let's say, the right edge, the left edge. I can align these 2. So it's very, very useful. Then I can align these components. I can align the top, align this top. So every, let's say, couple of minutes, you want to make sure that you're aligning, and really the program doesn't really care. It's gonna run fine, but it allows you to, in a way, have control over how this is going to grow, because very soon you're going to have hundreds of components in definitions. Okay, let's set the capping option to 1 for now, so it has this flat caps. And the last thing we're going to do, we're going to apply color to these pipes that we have. We know that right now what's controlling the color is this preview option here, which for some reason mine is buggy right now until I restart it. But that's the default the color here. And if anything that we have here, still we cannot select anything in Rhino, right? We're only previewing. If you want to then apply custom colors to any of this geometry here, we could use a component called custom preview. And anything that has to do with color, in Grasshopper it's been divided into two different menus. All the components that would allow you to input color, you would find them under params, input, and you have the second group of components here that would allow you to input color. For instance, it would allow us to input color swatches. So let's grab a color swatch from our input menu here. And a color swatch is quite similar to the slider component here. It doesn't have any input grips, but it only has output grips. If you right click on the color part of the color swatch, then it allows you to access this color wheel, and you could pick whatever you want this color to be. Now we have the color that we want to use, but we need to now have a component that would allow us to preview it with color, because we know that that's not the default setting of Grasshopper. So all the color information, you would find it under param input, but anything that has to do with analyzing color or previewing color, it's sorted under vectors, this color tab here. So all of this component allows you to extract color, analyze color, or preview color. So the component that we need is this one. All the way down here is called custom preview. And now we're looking at another type of a component. So color swatch only allows you to have output here. But this preview option here, which you would see this type of component which the end is cut off, these are only for previewing. So it only takes a geometry to preview, and it takes a shader information, meaning a color information, and meaning it could be the diffuse color or a color that has that you're using as a material. So it needs a geometry to preview. In this case, I want to preview my pipe with color. So let's input the P as the G input. The geometry is the bigger umbrella, right? So the geometry, anytime that you see a component that takes geometry input, it means it could take points, lines, surfaces, polysurfaces, and meshes. So it's the bigger range. So it's a flexible component that will take anything. So I'm inputting the surface output of this piping component into the G input of the preview. And by default, it has a color embedded inside here. And I'm going to change the color so it's slightly different. And now we could input this color swatch here, and you could preview it with whatever color you want. And I want to do the same for this second pipe here, for the top part. I'm going to copy this custom preview and the swatch components down. I'm going to replace the pipe with the second pipe, but obviously we don't want to use the same color. Is there anyone here that cannot see this surface with color? So above our canvas, there's this 3 different preview options. So by default, it's set to this red option here. This would allow us to see the shaded preview geometry. But we can easily then change the preview option to only look at wireframes, or no preview at all. So if you ever open your definition and you cannot see things, it's probably maybe you changed the preview option here. Sometimes previewing it with shader color, it might be a little bit heavy, so it might be good to preview it with, let's say, this wireframe option. The shortcut to go through all of these 3 options is Control 1. So Control 1 is this shaded view, Control 2. There's something, guys, I need to restart my Grasshopper, but if you go through Control 1, Control 2, Control 3, you would be able to toggle through these 3 options. For some reason, I cannot access any of these. But Control 1, Control 2, Control 3 would allow you to go through these guys here. Last thing we want to do, we want to turn off any geometry that we do not need to see. So if you click over this, you can see that we still have our point A, B, C, and we still have our lines, which might be okay, but it's not very clean, right? I see this third point all the way up here. So anytime that you get to a preview state, it's good to turn off everything else that you don't want to see. So I'm going to select everything else that's not being previewed. So we want to select everything except for this true custom preview options here. And once you have everything selected, we could use Control Q to turn off the preview here. Okay, so now let's save this file. So far, we've been working with a file that's not saved. Grasshopper doesn't crash as much as Rhino unless you get into really, really heavy files. And when it does crash, when you open it again, it does save the previous version. So it asks you if you want to recover. So it's quite good in that sense. So let's go to File and tell it that we want to save our document, or you can do Control S. And you can see that now we can use our file name option here.
Sorry.
So we're gonna call this point line pipe. You can call this, if you want to call this something else, introduction to Grasshopper, something else, go ahead. I'll be sharing this file with you at the end of the class, and pay attention to the extension here. So by default, Grasshopper files are written as .gh. So .gh is the Grasshopper file that allows you to, in a way, save the components the way that they are, meaning it gives you the file that would, when you open it, you access the components with the same thing that we're seeing right now. So it's writing them in a way that it could be then compiled and executed with these components. If you save your file as .ghx, the .ghx, it writes the Grasshopper file as an XML format. So you're basically writing a long text file, and it might be useful, but it's not really the default setup. So sometimes when you're on these forums, you might then find the file that's saved as a .ghx. It doesn't really matter. You can open either type in Grasshopper. So we're going to save this at .gh. And you can see that in title bar, the name is changing. Okay, so a few things before we end the class. But how do we then work with this geometry? Well, you can continue building your geometry in Grasshopper, but how do you take it into Rhino? For instance, how do you take it out of Rhino environment, put it in a different program to render it or do other things to it? So far what we're working with here is live geometry, because it doesn't really, the parameters could be adapted. At any instance, if you want to take your geometry back into Rhino environment, we do an operation that's called baking. When you bake geometry, let's, for instance, everyone right click on your first pipe component on the output, because the output is what's giving us the surface. If if you right click on the component here, you could see that we have this option here. The icon is quite telling. So it would allow us to bake this geometry, and when you select it, now we are accessing Rhino layers, right? So I need to be very careful because I cannot go through this operation if I have something typed in my command lines. So I want to make sure that nothing is in my command lines. If you, for instance, running an operation and then you come back to Grasshopper, then you decide that you want to bake, you want to make sure that nothing is in your command lines, because now we're finally trying to connect Grasshopper back to Rhino. So we're going to tell it to bake, and we can pick whatever layer system you have. For instance, I'm going to just take layer 1, and we can tell your geometry to be grouped or not. I'm only baking one geometry, so it doesn't really matter. You can, for instance, change the type. You can do all kinds of operations here. And finally, when you're when you have your right setting or desired setting, then you tell it to it's okay to bake it. Now that's a geometry that exists in Rhino. So this baking could happen anytime, and it could we can bake different types of geometry. So I'm going to turn off my preview here, Control Q, and I'm going to go back to, for instance, my line 1. I'm going to turn on the preview, Control Q, and now I want to bake that line. As I said, the baking needs to happen after the line has been created, right? So I cannot really bake the line here because this is still the input, right? But I could bake the line from this middle part or the output part. So I can either click on the middle part or the output part and tell it that I want to bake my line. For instance, if I want to send it to layer 2. So now I have different types of geometries that are being baked. Or I could bake my first point. I'm going to right click, I'm going to bake the point. But my everything else is still there, right? So if I turn on my preview, then now I have dead geometry next to live geometry. Last thing we're going to look at today is how to then reference geometry back into Grasshopper, because so far we've created geometry in Grasshopper, we are baking geometry out, but how do I bring back information in Grasshopper? So you're working with a project, the site boundary is very important, so we want to reference it back. So this is my baked point. I could reference this back, or I can construct a new point, it doesn't really matter. If you remember, under param, we said that this whole group of components here, they would allow us to not only, let's say, use input geometry, but also reference geometry or transfer geometry. So now we're going to look at how to reference geometry from Rhino. So under Geometry tab here, you can see that we have a lot of different geometry containers, and these are geometry containers. The reason that we're calling them containers, and in this case let's use the geometry point container, because I want to reference that point back into Grasshopper. It's a container because when we first look at it, it's empty. It doesn't really contain any information. So orange means it doesn't have enough information. If I want to then reference that point, I'm going to right click on the component here. I'm going to tell it to set one point. So go down the menu, and here where it says set one point, Grasshopper screen is going to be minimized. Now I can access Rhino. And I'm going to select that point, and we're going to reference that point back. And if I then grab a panel, I should see that this is a reference point. So I could then move this point around, and it doesn't really matter, because it's not really specific to the position of this point, but what this container is accessing is the ID of the point. What is the ID of the point, or ID of any geometry? If you select any geometry in Rhino, whether it's a point, line, anything, if you type list, so the command list would allow you to access, in a way, the ID of this geometry. So this long number here, this UUID, it's very specific. It's to this instance of point that we've created in this file. And here we can see the coordinates. Another way that we can access this ID is by typing in the command what. So if you have no idea what you're doing, so type in what, select your geometry, and it would allow you to access quite similar information. So therefore, when we're referencing geometry this way, then we're accessing that ID. So therefore, the coordinates could change, but we're always, we know that that's the point that we are following, right? Last thing we're going to do, let's also reference back this curve. So under parameters, geometry, now I need to look for a component that would allow me to reference this geometry. What is this? If I type list, it tells me that this is a curve. So what that tells me is that I could use a curve geometry container. So again, it's an empty container. And I could right click and tell it to now set one curve. Now that curve is also referenced. So very important note, because now I'm referencing geometry from Rhino, then if I'm saving this file, and if these are crucial geometry to my file, then I need to make sure that not only saving my Grasshopper file, but I'm also opening this very specific Rhino file before I access this Grasshopper file. If I don't do that, I'm going to close it, close Rhino. Now I'm just opening different file. You can see that now I'm missing that information, right? Because that geometry doesn't exist anymore. So you want to make sure that you're always saving. If the information is important, you want to save the Rhino file with the Grasshopper file. And it's common convention to then give them the same name, because then it will be easier for you to go back and find them. Okay. Any questions? Okay. I will give you this file along with a few other examples right now. So if you could give me your emails, perfect. Thank you. So what I really recommend is to go through the Grasshopper primer, which is, you will find it here on the front page. Just go through the example files, and it shouldn't take you more than a few hours. Download the PDF. It's a really great resource. So you could stop pretty much anywhere or right when they start to talk about data trees, and that's what we're going to start to look at next week. Thank you.
Thank you.